Hi everyone, thanks for coming. And today we're going to talk about development experience and how it came to be, but we decided to improve it. And yeah, so the first, just a couple of words about our company. So we both work for Maersk Engineering, Andre and Simon. And Maersk is a global logistics company, and just to give an idea that if you look around and maybe something you see or something you wear, had been at least once through our supply chain on our vessels, terminals, trucks, etc. And logistics is a very competitive industry. So, and in order to stay ahead, we need to keep the innovation going. And what innovation needs, it needs good business ideas, and it also requires us to validate these business ideas as fast as we can. And for that, every participant in the validation or in development of those business ideas need to be as productive as they could be. And what we wanted to understand, because we work for technology, is our developers, are they productive? Are they blocked? Do they have what they need to build things? And we formed a work stream, which is, surprise, called Development Experience Work Stream. And this wonderful team went after developers. They conducted numerous interviews, surveys, analyzed the pipelines, code repositories. So they did tremendous work, and huge credit to them. And what they came up with was not entirely pleasant. So we figured that we had a small problem. And apart from running out of the corporate stock images, well, the problem was that our developers were spending a lot of time on building the infrastructure instead of just releasing the applications. And in fact, it was about 70% of time based on the feedback which they spent on that. And also our infrastructure delivery was not very optimal. So it took about between 3 weeks to 3 months before developers could actually have the actual infrastructure to deploy the application into production. Because it all included the checking the security, making sure that you get the actual infrastructure, like things like that. So here's the problem we have, and in order to actually understand the problem, we decided to reason and understand our current state. So normally when you find yourself in unfamiliar city or in a large city like London, right? So if you want to go somewhere, you need to understand first where you are and where you want to go and how to get there, and for that you use map. So here you can see a framework which we use to rationalize about what we have, and it's called the Wardley Mapping Framework. If you don't know Wardley Mapping Framework, so you can Google it and read about it. It's a very good framework to reason about the problem. But in a nutshell, the framework focuses on two things. One is the user needs, and second thing is that its component evolution from being the very bespoke to being the standard. So what we did, we mapped our problem. So on the left-hand side, you see the situation we found ourselves in. So we have the developers. Developer needs user experience, preferably good user experience. And our user experience was a pull request in one of the repositories. And the problem was that each repository was owned by an individual infrastructure team or resource manager, and the team were serving customers directly, and effectively they had their own bespoke processes when it came to actually serving the services. So developers were deeply frustrated, but the infrastructure teams were super happy because they were dealing directly with customers, and everybody was thinking they were doing a great job. But based on the feedback we received, it was not the actual case. So we decided, okay, so then let's see what developers wanted to have, and let's see how we can make it happen. And based, again, from the feedback from developers, they say, okay, we would like to have something simple, something like Portal, where we can go in and request our infrastructure and deployments and manage everything And some group of developers say, well, we really like to do the infrastructure as code. So we wanted to keep those experiences which we wanted, and we wanted to make some experiences which we wanted, again, as a portal. We didn't have it. So, and in order to have it, we needed an API, because right now we had a pull request, but if we have an API, then we could build anything, or we can build any experience we want. And well, that's for simplicity called infrastructure API. And this infrastructure API required our resource providers to also provide an API first approach instead of doing the pull request. And so we figured, okay, it's a brilliant idea. This is where we want to be. Then developers ask for it. Then it's a great thing. So we went to our infrastructure providers and say, well, guys, how about you change the approach with the way you serve people from being pull request to being the API first? And surprise, surprise, they hated it. So because everybody were happy and things were doing just fine, and like a couple of blocks came in and say, well, let's change the whole thing, right? So then nothing was fancy. So we had to sit down with each team. Well, some teams, they say, well, yeah, they absolutely love it, but some teams say, well, yeah, but why? So we sat down with teams and explained to them the whole process and what developer wanted, what we wanted to do for business, and this is the value which we will bring. So, and finally, we got everybody on board with it, and teams decided, okay, yeah, let's do it. So once we decided, okay, this is how we do it, so we architected the framework. So we had 3 architectural layers. One is the user experience layer. On user experience falls everything like portal, infrastructure as code. Developers can also call APIs directly. We don't prevent that. So somebody with a better idea than us can build the user experience they want using just the APIs. Then we have a control plane layer. The control plane layer serves the actual customer-facing infrastructure APIs, which developers or user experience layers is going to call. Then we introduce the reusable components, because otherwise resource providers would have to implement the same component all over again, like the audit history service, advanced search, notifications, approvals, etc. Then we added a bit reason to our madness, so we wanted to put a structure. So we introduced a concept of a team, and a team represents a team of developers, and the team of developers own one or multiple applications, and resources are created for application. So we have this kind of model other than the control plane. Plus, we added a secret engine because resource managers or resource providers could use secret engine to exchange secrets with applications or with development teams. And development teams also use the secret engine to manage application configurations. Yeah. And finally, we have a resource management layer. And the resource management layer is owned by each individual resource provider. It provides the control plane facing APIs, so resource managers or resource providers do not serve customers of our platform directly. They provide APIs for the control plane, and they manage the lifecycle of resources. Plus, they can borrow some reusable components which we put in the control plane. And what we also had to do is we introduced the common API standard across our infrastructure provisioning flow or infrastructure lifecycle management. And guess what? It was not loved again. So because we provided opinionated standards, and we asked all the teams to implement it, and again we had the reasons why we needed to do it, because we wanted to build consistent end-to-end integrated experience. So eventually teams warmed up to that, and they've seen the reason why we actually proposed that. But this API standard had few principles which we put in place. One is that everything we do has to be application scoped, because application is our factory anchoring point for all the resources. Then each resource provider had to statically declare resource types in the open API specification, because in the way we onboard resource providers, we kind of pumped the open API spec into the control plane and populate the resource provider catalog from it. And what we also wanted to give resource providers is freedom of expression. because the resource providers are the ones who are actually providing the interface for the user experience, so they also know better how to create resources. So they need to be able to evolve and define their schema in the way they want it. Every operation we do through our control plane is durable and asynchronous. I mean, lifecycle operation, like create, update, delete, etc. And each operation must be accompanied by the pipeline. So whoever requests the resource lifecycle management operation could also always come back and check how it is going. And finally, we created implementation guidelines and blueprints. So the first one is to use Temporal, because it will save you time and mental energy. There are some teams who decided not to use Temporal. I don't know why, but they were really opinionated. But based on our stats, teams who use Temporal produces production-grade endpoint from between 2 to 3 months. Teams who doesn't use Temporal, probably we spoke to the team 12 months ago, they're still figuring it out. So yeah, so pick your poison, I would say. Then what we recommend is that you set your workflow ID to resource ID, because we wanted to avoid race conditions on the resource lifecycle operations, and Temporal provides this out of the box, so you cannot run, you cannot have basically 2 workflows active at the same time or running at the same time, and this is easy win for us. When you're providing the pipelines or managing pipelines, then we recommend setting pipelines to pipeline ID to workflow run ID and maintaining pipeline inside the workflow as a state, so you could use workflow queries to get the latest status of your lifecycle management operation. Again, super easy with Temporal, but we don't really care about the pipeline, and pipeline information is gone after retention period kicks out the workflow from the system. And finally, we use revisions, and each resource object have a revision ID. That's how we are dealing with the kind of offline concurrent object updates, because we, for instance, if there are multiple clients, they pulling down the object, the same object copy from the server, then only one client should win. Other clients should actually go back and refresh the object. So we fail requests which do not have matching revision IDs. And finally, with all that, we had the control plane. We had the resource providers who are building APIs, integrating them through the control plane. We had the API, and we are finally ready to build the golden path. And I'm handing over to Simon to talk about that.
So Andrei mentioned a lot of building blocks, a lot of fundamental solutions that should bring us a consistent infrastructure for the DevX project. However, what we were missing still was a golden path, was an actual DevX tool. And to build it, to improve the experience of the engineers in Maersk, there are like more than 3,000 of them with different level of maturity, we started to think what could be the golden path for them, how it should look like, what should it bring, except just all the tooling that Andrei was mentioning. So taking into account what I've already mentioned, the fact that the maturity level is different between them, and also what Andrei was saying, the complexity of the whole infrastructure that is at the moment present in Maersk, we've decided that our key element is standardization and simplification. So looking at the Maersk ecosystem and all the arrangements around infrastructure, there are like hundreds of different ways to deploy your workloads to production. We've decided that this is the situation that must be changed, and that was our primary goal, to remove all this mess and replace it with a common way, a kind of a hand-holding for all the people to deliver the actual business value. So let's go back to the beginning of this journey. The first task that we've decided to develop, to execute, was to create kind of a POC of deployment engine. So before that, engineers, or still now in Maersk, engineers are forced, like backend engineers, Java engineers, like C# people or others, they are forced to manage also the infrastructure. They are often asked to create Terraform scripts, manage flags or other tools. And as you can imagine, it ends up with really weird solutions. So what we've decided to achieve is that to leave the continuous integration on the engineer's side, but from the moment when the Docker image is created and pushed to the repository, the responsibility is on us to take it and to place it in the reliable infrastructure, to host it ourselves and expose it to the outside world. The initial feedback was really positive, and the engineering community was quite optimistic about it. They were interested in using it. So the next step was to enhance it further. And Andre already mentioned about the resource providers. That's the upper blue rectangle. And in Maersk, at the moment, we've got already teams that are responsible for providing particular resources, such as Kafka, such as Temporal, such as database. Either it's SQL or document databases. There are also like CDN and few others. The goal of IDP, Internal Developer Platform, is to bring all these solutions using the common APIs to the user. So we are building the UI that allows every engineer within 3-4 clicks to get a database instantly, without waiting, without one manual approval. So the thing that is crucial for us is to enable an engineer to bring the business value without spending time on managing the infrastructure. Except purely resources as we understand them. The thing that platform is also bringing to the engineers are security standards, is support for monitoring, some initial dashboards, initial setup of tracing and logging. So all this stuff are brought to the engineers just without any additional setups. The building blocks that we are using for that is for CI, it's like GitHub Actions. Then we've got Harbor for the Docker image repository. Then we've got Temporal to orchestrate our work, and Vault as a secret storage, and Kubernetes to host the infrastructure, to host the actual deployments. And here we are coming to the Temporal and the importance of that for us. On the right side of the slide, you can see a simple pipeline. That's creation of the new application for an engineer. So there are several steps there, like creating new project in Harbor repository, setting up the GitHub repository for code, pushing some initial version of the project with integrations, with some samples that engineers can rely on during the development. All the steps must be controlled and executed. We need to make sure that the process was successful. And if you had a chance to listen to the durable execution speech, that's exactly what we are achieving through the Temporal. We are getting the orchestration. We are getting the resiliency and reliability. We don't need to write our own state machine that probably each of us has done a few times in our life and understand how difficult it is and how many pitfalls are waiting for us during this process. The last thing that Temporal brought for us, and it's still super important, is the transparency and debugging. So during the development process, thanks to the visibility of the workflows, the way that Temporal exposes the information about the scheduled actions, we are able to really quickly identify the bugs, mistakes that we've done, or some issues in the workflows, and apply fixes, change them, improve. The additional thing that we've added on top of Temporal is a cache layer, so some persistence layer. At the moment, since we are self-hosting Temporal, the persistence of workflows is only 72 hours, and that's not acceptable for our clients, that is engineers. So we must be able to show the pipelines that we are executing that were triggered by the engineers even after a few weeks. So that's why we are keeping additional layer. It is also quite convenient if you're thinking about exposing this data further to the UI. So the search through inside the persistence layer is quite easy, and the data structures that are kept there can be almost without any additional modification pushed to the front end and presented there. So the last slide are learnings, and here Andre will come back.
Yeah, let me wrap it up. So thanks, Simon. So the first thing is, I think we need to go through the learnings, right? So the first learning we found is that, or we recommend, or we wish we did, is to introduce a portal which covers all our current offerings in one place, because we didn't have the portal, and you can probably start with a simple HTML page where you list out all your services which you are providing, and then evolve this page from being a simple static page into the actual site which provides good user experience. So then developers have all the content from the day one, and this was one of the findings which we wish we did sooner than later. Then you need to have a technical product owner. As product owner will drive the product and will cheer for it, maintain backlogs and feature sets. Like basically, it's a face of the product. It's essential. We need to have common integration standards, and we just have to do it, because if you're building something with end-to-end experience, then you need to have all the components integratable throughout the journey. Regularly engaging with development and presenting the new features, getting feedbacks, and improving the product is one of the essential things which you need to do if you embark on this journey. Preparing for the pushback on all fronts. So yes, we got a lot of pushbacks. We had to deal with a lot of I would say explaining things to people, and also we got pushbacks from some developers, because developers who spent last 12 months learning Kubernetes didn't want to lose this learning, because we make it super simple and we say, well, you don't really need to learn Kubernetes and spend 12 months doing it. Not everybody liked it. So, but end of the day, after getting the value out of the product, they can see that after 5 minutes they can get something live, which used to take much longer. Then you need to fight everything with the data. You need to set up your metrics against which you will be benchmarking your deliveries. So if we say we need to improve infrastructure delivery from 3 months to 5 minutes, then this is going to be a metric, and once you hit it, then you hit your promise. So track your metrics, make sure you have them. And the final piece of the puzzle, we had to bring all our Scrum teams who were contributing to different pieces of our control plane and development experience into one backlog, or say one view with multiple backlogs, so everybody would understand why they're doing it and what is the outcome of this contribution we're doing right now and how it is going to impact a bigger picture. So that's it. Thank you.
Okay, so we have time for about a few questions, and you had your hand up first, so here we go.
I'm just wondering, what is your IDP base? Is it like totally custom solution or based on some open source?
So yeah, I can respond to this one. So we analyzed around 5 commercial products and some of the open source, and we've ended up with a conclusion that to make it simple and to adjust it to the people who are not that experienced, and this is also the goal. Even if you rely on already existing IDPs, you will need to create a layer on top of it. And in the same time, when we were introduced to some commercial IDPs, we got the feedback, guys, you will get this tool, but you will need to have like a team of 5 people who will be managing it. And this was quite confusing, because like in such a setup, why do we need your tool if we need to like maintain it and kind of rebuild it? The other part of this whole picture is that Maersk is a huge organization with quite a legacy, with quite a history. And we cannot just tell people, like, it's from the kind of a psychological perspective, it's impossible to tell people to leave their current solutions, like technical, like resource providers. They were working on exposing Kafka for a few years, and this is already kind of a major solution. But Backstage or any other tool is not going to integrate with it, because that's a custom made. So we've decided to go with a fully new product. Probably, if we are in a situation when it's completely greenfield, then most probably we would rely on already existing stuff. But in such a case, it wasn't an option.
Thank you. Makes sense.
So I see that you manage a lot of these infrastructure resources. So I wanted to understand the life cycle of the workflows. So are there really long-running workflows which stay alive, or is it jobs to be done sort of workflows?
No, the longest running workflows are around up to 20 minutes, because that's the time of setting up a database at the moment for us in Azure. So generally, the thing is, that's also related to the goal of the whole project of IDP in Maersk, is to bring things within 5, 10, maybe 15 minutes, but not more. You should get instant response on your request.
So just to add to that, so because in the way we design the APIs, they can run for months because we have Temporal backing the whole thing, and then we have the pipeline resource which you can always come back and check what is pending. And right now, like Simon says, we don't have the workflows with human in the middle. But if you can imagine, there could be some topics or can be some APIs which would require approval for the different reasons. And then once you have a human in the middle, then your process becomes complicated because human need to click on something, and that might take a week. But yeah, so our design allows almost indefinite run as long as Temporal is up and running.
Hi, Andrew. So are you happy with self-hosted platform for Temporal, or you are also planning to migrate to the cloud?
Right now, we're happy with our self-hosted setup, but we're also exploring options, and we would like to check out the cloud as well. But right now, we're self-hosting. Yeah.
Last question.
You talked a lot about preparing for pushback from developers, which we commonly do, but what kind of metrics are you capturing to prove your value to the business?
It's DORA metrics.
I'm sorry?
Capturing DORA metrics, I think. Yeah.
What
DORA
kind of metrics?
Also, we've got clear metrics on setting up an application. So from the moment when the person requests an application, he ends up with an endpoint already exposed either to the world or internally within few minutes. Additional metric is like the metric is aimed at 0. There is 0 human interaction. Like Andrzej said, Temporal is able to accept feedback from the real person. But for us, the ambition and the metric, like the goal, is 0 human interaction. There shouldn't be any people in the middle who will be arbitrarily deciding if this application can go further or not. So, yeah, I guess that's the thing that we are measuring. It's also like it's hard to measure the actual pace of development, but we can see from the rather descriptive feedback that people are really relieved without the burden of maintaining, for example, the Kubernetes and like organizing deployment there.
Yes, because with some developers it happens. So we got a pushback. We ask them to try. They love it, and they don't want to come back to what they had. So some things just have to be tried.